Welcome back to the deep dive. This is where we take the sources you send us and, well, really dig into them to pull out the core ideas. And today, this deep dive is built just for you, the learner. You sent over a document title, very specific, Star-Delta Contactor Wiring Setup. So that's our focus. We're zeroing in on exactly what that phrase tells us.
That's right. Mission accepted. We're looking squarely at the practical side, the actual implementation suggested by that title, Star-Delta Contactor Wiring Setup.
Yeah.
It signals we're moving past general theory, like basic three-phase power, and into the specifics of putting something together.
Okay, let's unpack this, because the title itself, Star-Delta Contactor Wiring Setup, it's quite precise, isn't it? It tells us exactly what the source is about.
It really does. Let's break it down. We've got Star-Delta, which points to a specific motor starting method. Then Contactor, the hardware doing the switching. And finally, the really crucial part here, wiring setup. The focus is clearly on how those wires are arranged, the configuration.
Right, the wiring setup part.
Right.
It implies the document isn't just about what a star-delta system is, but very specifically how you connect it, how you actually arrange the conductors.
Exactly. The physical connections, the layout. What's fascinating here is that phrase locks our focus. The source material you shared seems entirely geared towards the practical arrangement of wires for this specific type of contactor system.
So let's circle back to that full phrase one more time. Star-Delta Contactor Wiring Setup. It's specifying the contactor part within the Star-Delta method, and particularly the setup of the wiring for that contactor. It's drilling down quite deep.
It is. And if we connect this to the bigger picture, like why this setup even exists, the source material is anchoring us right in the assembly process. The wiring setup is the bridge between the components, the Star-Delta contactors, and making them actually work together correctly. The document seems focused on that relationship.
Before we get lost in the wires, though, maybe we should touch on why this setup is needed. I mean, why not just switch a big motor on directly? What's the danger?
Good point. It's all about managing surge current, or what's often called inrush current. Imagine a really big industrial motor just sitting there.
Yeah.
When you hit it with full power instantly.
Yeah.
Well, for a split second, it acts almost like a short circuit before it gets spinning and generates its own sort of counterforce, electrically speaking.
Okay, so if a motor normally uses 100 amps, it could spike to, what, 600, maybe 800 amps? Just for a fraction of a second.
Exactly that range.
Yeah.
6 to 8 times the normal running current. It's a massive jolt.
Wow. And that's got to be rough on the equipment, right?
Definitely. It stresses the motor windings. It hammers the mechanical parts connected to it. And crucially, it can cause a big voltage drop across the whole electrical system.
Which could mess with other machines on the same line?
Precisely. Lights might dim, other sensitive equipment could trip offline. It's a system-wide problem.
Right. Okay, so the Star-Delta part of the title refers to the solution for that problem.
Yes, it's the classic way to deal with it using electromechanical parts. A reduced voltage starting method.
And the wiring setup part of the title, that's the instruction manual for building that solution.
You got it. The wiring setup is the mechanism that controls how the motor starts gently. The whole idea is to start the motor in one configuration, the star configuration, which uses less voltage.
Star, right, sometimes called Y.
Yep, star or Y. Lower voltage means lower starting current. Then once the motor's up to speed, maybe around 80% or so,
Then you switch it over.
then you transition it to the delta configuration. That's a full voltage mode for normal running.
And the voltage reduction in star is significant.
Oh yeah, it gets about 57, 58% of the full line voltage. Mathematically, it's 1 over the square root of 3.
So less voltage, less current surge. Makes sense. Protects everything.
Much less current. Maybe only 3 times the normal current instead of, 7 or 8 times.
Yeah.
Much gentler and everything. So the Star-Delta Contactor Wiring Setup document is essentially detailing how to mechanically and electrically achieve that two-stage start.
Okay, let's talk hardware then. The setup involves specific components mentioned implicitly. It's not just one big switch. What are the key parts the wiring connects?
You're typically looking at 4 main things connected by this wiring setup.
Yeah.
There are 3 contactors. Those are like heavy-duty relays or switches.
3? Okay.
Yeah. They're usually called the main contactor, the star contactor, and the delta contactor. And then there's a timing relay.
Main, star, delta, and a timer. Got it. The main one sounds simple enough. Just turns the power on to the motor.
Pretty much. The main contactor connects the power lines to the motor windings, whether it's running in star or delta. It's always involved once the motor's on.
Okay. And the star and delta contactors, they handle the configuration switch.
Exactly. They control how the motor's internal windings are connected. A standard three-phase motor usually has 6 connection points, 6 terminals.
Right, sometimes labeled U1, V1, W1, and U2, V2, W2.
Those are the ones. During the start phase, the star contactor does a very specific job. It connects 3 of those terminals, usually U2, V2, W2 together.
Connecting the ends of the windings.
Yes, creating a common neutral point. That's the star configuration. It's only active during the initial startup.
And the Delta contactor waits its turn. It only closes after the timer says go.
Correct. When it's time to switch to full power, the timer triggers a sequence. The star contactor opens first.
Breaks that common connection?
Right. And then the Delta contactor closes. Its job is to reconnect the windings differently into start, essentially. U2 to V1, V2 to W1, W2 to U1. That creates the delta triangle.
Completing the delta shape, yeah. And that gives the motor full line voltage across each winding for normal operation.
Precisely. Full power, full speed.
Okay, so this brings us right back to the core of the source document title, the actual wiring setup. We know the parts, we know the sequence, but what makes a good setup, a safe setup? It must be about how those connections manage the transition, right? And protect against things going wrong.
Yes. What's fascinating here is the real intelligence, the safety, isn't usually in the big, thick power cables. It's in the thinner control circuit wires. That control wiring dictates the whole sequence. Main on, timer starts, timer finishes, star off, delta on. And crucially, it must include safety interlocks.
Ah, interlocks. Okay, connecting this to the bigger picture like industrial safety. This sounds critical. Why are interlocks so non-negotiable in this specific setup?
Because of the danger we hinted at earlier. Think about what happens if the star contactor and the delta contactor are both closed at the same time.
Uh-oh. Star connects the ends together, delta connects end to start if both are closed.
You create a direct short circuit across the main power lines, phase-to-phase short. It's instantaneous massive current.
Catastrophic, I imagine, like sparks, fire.
Absolutely. An arc flash, explosion, blown fuses or breakers, serious damage to the contactors, the motor, everything. It's incredibly dangerous.
So the wiring setup absolutely has to prevent that overlap. It has to guarantee it's either star or delta, but physically impossible for it to be both.
Exactly. And a proper wiring setup builds in usually 2 layers of protection for this. First is the electrical interlock.
Okay, how does that work in the wiring?
The control power going to the coil of the delta contactor. It has to pass through a special auxiliary contact on the star contactor, a normally closed contact.
Normally closed, meaning it's conducting electricity when the star contactor is open or off.
Right. So if the star contactor is closed, energized, that little auxiliary contact opens up, breaking the power path to the delta contactor's coil.
Ah, clever. So if star is physically closed, delta literally cannot get the signal to close.
Correct. And it works the other way too. The power for the star contactor's coil has to go through a normally closed auxiliary contact on the delta contactor.
They electrically block each other. If one is on, the other is locked out. That's elegant. That's the control wiring setup doing its job.
It's self-policing, as you say.
Yeah.
And often, especially in critical applications, there's a second layer, the mechanical interlock.
Mechanical, like a physical blocker.
Yes. It's often a piece of plastic or metal physically linking the moving parts of the star and delta contactors. It's designed so that if one contactor's armature pulls in, it physically prevents the other one from moving.
Wow, so even if the electrical interlock somehow fails, this physical piece stops both from closing?
That's the idea. Belt and suspenders. The complete wiring setup really relies on both these interlocks being correctly installed and wired as part of the control circuit.
Okay. Let's walk through the sequence again, thinking about how the wiring controls it all. The timing is everything.
Right. So you apply power to the control circuit. Step 1, the coil for the main contactor gets energized, and the coil for the star contactor gets energized at the same time. Power flows, motor starts turning in star. Reduced voltage.
And the timer starts ticking right away, too.
Yes. The timer coil also gets power immediately. So main on, star on, timer running.
Motor's accelerating. Current is lower than a direct start.
Much lower. Then, after the time you've set on the timer could be 5 seconds, 10 seconds, depends on the motor size and load.
The timer reaches its set point. What happens in the wiring then?
The timer activates its contacts. First, it opens a contact that cuts power to the star contactor coil.
So the star contactor drops out, opens up.
Exactly. And here's a subtle but important point in many setups. There's usually a tiny delay, maybe 50 milliseconds or so, programmed in or inherent in the way the contacts work.
A pause. Why?
It's called the open transition. For that brief moment, the main contactor is still on, but both Star and Delta are open. It helps prevent current spikes or arcing during the switchover. A clean break before make.
Gotcha. Little pause for safety. And then,
Then the timer closes its next set of contacts. This energizes the Delta contactor coil.
and now the Delta contactor can close because the Star contactor is definitely open, satisfying the interlocks.
Precisely. Delta pulls in, connects the windings for full power. The motor settles into its normal running speed in the Delta configuration. Start sequence complete. Inrush current. Successfully managed.
So the key takeaway from a source titled Star Delta Contactor Wiring Setup isn't just listing the parts.
No, not at all.
It's the setup. It's the specific way those control wires are routed to guarantee that sequence, especially the interlocks and the transition timing.
It's the practical instruction set.
Yeah.
How to connect A to B through C to ensure D happens before E and F never happens at the same time as D. That's the core value proposition of a document with that title.
It's like the source is saying, the power wiring is obvious, L1, L2, L3, go here. But the control wiring that needs this specific ladder logic to be safe and effective, the setup is the safety procedure embedded in wires.
It really is. It's control logic made physical. Get the wiring set up right, following those instructions, and the system works safely for years. Make one mistake in the interlock wiring.
And you could have that catastrophic failure the first time it tries to transition.
Instantly. That attention to detail in the setup, that's likely what the source material is all about.
So what does this all mean? Looking back at our deep dive, prompted by just that title, Star Delta Contactor Wiring Setup, it seems clear the source material is focused on the practical, hands-on instructions for building the control circuit. The goal is managing that high motor starting current safely. And the absolute heart of that setup is ensuring the Star and Delta contactors cannot be on simultaneously, using those electrical and maybe mechanical interlocks in the wiring.
Which leads to a really interesting question for you, the learner, to think about. When you see a technical phrase like this, one focused on practical steps, Star Delta Contactor Wiring Setup, what becomes most important for you? Is it understanding the underlying schematic, the theoretical logic diagram? Or is it mastering the physical steps, ensuring those safety interlocks are wired correctly, robustly, and properly tested during the actual setup? Where do you prioritize your focus?
That's a great point. It highlights how crucial that physical implementation of the setup is. Even the best design fails if it's not put together correctly, especially when safety is on the line. Well, thank you for sending in that source title. It sparked quite the deep dive into the nuts and bolts of this specific electrical configuration. That's all for this session.